So we've done problems like this before, where I say what two numbers add to this, multiply to this, and we've done those. But I don't know if you had noticed before, but all of the questions where we'd done that before, they were all positives. And now I'm throwing in a negative. And that's going to be the new twist and the new theme with these, is we're going to have to be able to do these with negatives in there as well. And so it uses that information that we were talking about end of last week about negatives, where we made sure that you had all those little details down. So for this one, I want to figure out a couple things right at the start. Like, what will the signs be of my two numbers? Well, I want to multiply to 70. And notice that's multiplying to a positive 70. So what are our options? Yeah, there's two different ways we can multiply to a positive number. We can either do positive, positive, or we can do negative, negative. Either of those will end up giving us a positive number when multiplied. Basically, if the numbers are the same, they multiply to positive. But in this case, we want to add then to a negative. Okay, so which one's it going to be? Is it going to be the positives or is it going to be the negatives? The negatives, absolutely. And so right there, I know that my answer is going to be two negative numbers. And that's what I want you doing first. Whenever you see these types of problems, is start by figuring out what should the signs be. All right, so now that I know that, I now can focus on the 70 and the 17. Since both signs are the same, the thought process is the same. What multiplies to 70 adds to 17. And what would those two numbers be?
Negative 7 and negative 10.
Yep, exactly. It'd be negative 7 and negative 10. Or you could also write it as negative 10, negative 7. Either way, doesn't matter. They both mean the same thing. The order of the numbers does not matter with this. So in this case, again, I want to start by thinking about the same thing. What will my signs be? And whenever I'm thinking about these problems, I always start with the multiplying number. So that's why I look for my signs as well. I'm multiplying to a negative 20. What does that tell me about my signs? It tells me that there's a negative and a positive, yes. They both can't be the same, because remember in the last one we saw that if they're the same, they multiply to a positive. You know that you're going to have one of each. So the only question then is, well, what will our two numbers be? And then which one's positive and which one's negative? Now, when thinking about these, because one is positive and one is negative, our two numbers, if we strip away the signs, it's like they're actually going to be just one unit apart from each other. And so I just start thinking about all the ways I can multiply to 20 here. So like 20 times 1 would definitely not be it, because those things are 19 apart. They're way apart. Or I might think about, say, 10 times 2, but those are 8 apart. They're a long ways apart. What are the closest two numbers to each other that I can multiply to get 20?
4.
Yep. 4 times 5. And so we're going to use that. All right, so we know it's going to be 4 and 5. The question, though, is which one's going to be positive and which one's going to be negative? And there's a little trick to be able to tell that. Our answer that we add to here, notice it's a positive. That means that of my two numbers, I should have more positives than I have negatives. And so the bigger number then in this case will have to be the positive. So I'm going to call it a positive 5 and a negative 4. Or again, you could switch the order. You could write negative 4 and 5 as well. That's perfectly fine. But notice there, the number that's negative doesn't change. When we switch the order of them, the 4 still has to be the negative and 5 still has to be the positive. So we have this situation where a caterpillar is climbing up a tree, and we know it's starting out 4 feet above the ground. And it's going to continue to climb 6 inches each minute. Now already I noticed that I started with feet and now I'm in inches, so I'm going to have to deal with that here. Now how high will the caterpillar be in half an hour? Now every person is going to potentially think about this one and approach it slightly differently. I'm a very analytical kind of person. That's why I'm a math teacher. So I tend to start by taking this and representing it with symbols and numbers. You know, basically I write an equation and then solve an equation for it. But that's kind of atypical. Not everybody's brain works that way. And so I want to be talking instead, what are strategies that you use to figure out real world kind of problems? And one of the great things to do is draw a picture. And so draw yourself a little tree. Now, I'm not artistic. This is about as good of a tree as I can make, all right? Oftentimes my tree would just be a stick. But it's useful. It gives me a starting place. And I want to put my caterpillar on the tree. All right, so I put a very creative looking caterpillar on the tree. But when I do that though, the big thing is I want to be able to have this picture help me out. So I go ahead and I write that the caterpillar is 4 feet above the ground at that point. It's just going to help me to kind of strategize that. All right, now I want to figure out how high will the caterpillar be in half an hour. Okay, now I have to go deal with this part about how fast he's climbing. Because he's climbing 6 inches per minute. So I could go and say plus 6 inches like that. So in a minute, he's 6 inches higher. If he goes 6 inches higher, how high above the ground is he?
4 feet 6 inches.
Yeah, it'd be 4 feet 6 inches. Okay, what if he goes another minute? Then how high is he?
5 more.
Well, that's another 6 inches higher. What would that bring us to?
5
That'd be 5 feet. Now, why? Because 6 inches is how much of a foot? Half. And so, personally for me, I don't like trying to keep track of the inches and the minutes all separately. Or, sorry, inches and feet all separately. I like to just put it all into one. So when I look at this, I actually say that I am going to start at 4 feet. But then I say that I'm going up by 0.5 feet per minute. I think of it all in terms of feet. It just makes my life a lot easier. Okay, so I'm drawing my picture there, so I got up to 5 feet, and I got to keep going up. How many times is this caterpillar going to go up by 6 inches? 30 times in this problem, yeah, because it's 30 minutes in half an hour. So I got to do that 30 times. All right, so if I go up by half a foot 30 times, that means I'm doing that half a foot times 30, which is what? What's 0.5 or 1/2 times 30?
15.
It's 15. Now, having found that though, you notice we're not actually done. The answer is not 15 feet. Because remember that we started 4 feet up. And so the last step is then you take your 15 and you add the 4 to it. So you end up with a total answer then of 19. Now I don't want to say my final answer is 19. I want to say it's 19 feet. And why? Because some of you didn't do it in feet. You didn't change everything into feet like I did. You changed everything into inches. If you did that, that's perfectly fine. Your answer would have been 228 inches. And that's perfectly fine. There's nothing that specifically stated that it had to be one way or the other. Either of those answers would work. And so when you're looking at a problem like this, again, there's multiple routes for multiple people, and you can take different routes on this. Some of you are going to go totally analytical. You're like looking at this and you're like, all right, I know exactly what I'm going to do. You're going to write down the 15, the 4, some mathematical operations, and you're going to like do the math. That's fine. But what if you aren't seeing that? What do you do? Because a lot of times, yeah, I mean, we're kind of starting with kind of simple problems in their own way. But it's really about learning how do we digest through some of this stuff. Because if I just gave you the math, you could handle the math. But how do we do it from the question perspective? And a great strategy is, again, to draw a picture. Now, you don't have to make them all happy people. They're hiking. They could be struggling up the hill for all we know. Heck, you could even just make them rectangles for your pictures. The key is that we want to have 4 different containers in which to split up our 15 quarts of water. And so a nice strategy with this sort of thing, let's say you aren't quite sure how to approach it, just start divvying up the 15. So I'm going to try to give everybody a quart. So here's a quart. 2, 3, 4. Okay, so everybody gets at least 1 then. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. now we hit our end. And you can see that we ended up here with an uneven amount, right? And so we need to see how do we deal with that kind of a situation. Because we do want to share the load equally here. So that last one, I actually don't want to give everybody that full last one. So everybody gets 3 full ones. We can see that. But remember that I had 3 left that I had to split up amongst all 4 people. If I have 3 quarts and I'm splitting it up between 4 people, how much should each person get?
3.75.
And so for that last part, if there's 3 there, and they have to split it amongst 4 people, basically you're doing 3 divided by 4, which most of you tend to like to do that in your calculator, and you get a decimal like that. But you know, when I look at it, I think it's, 3 divided by 4, 3/4. Basically, each person is getting the 3 wholes plus that 3/4, and so each person then is getting 3 3/4 if you like fractions, like I do, but some of you don't like fractions, so you gave your answer as 3.75. And so, as some of you are already pointing out, you could have gone straight there by doing the 15 divided by 4. And again, that would give you that same 3.75 quarts per person, or 3 3/4 quarts per person. All right. Last problem for us to do together. Go ahead and write down and process through this one. So what normally ends up happening with this question is the first thing that people start asking is, well, how many pieces of pizza are there? How many pieces is each pizza cut into? And we don't know. It could be cut into 8 pieces. It could be cut into 12 pieces. We simply do not know. But we could cut it ourselves if we wanted to, or we could figure it out and then go based on it, but we don't know how many pieces this particular set of pizzas is actually cut up into. And so if I know that I need to take these 2 whole pizzas and still figure out how much does each person get. And there's multiple ways you can go about it. I think one of the most intuitive ways to do this is to think about, okay, if I have 6 people sharing 2 pizzas, how many people share 1 pizza?
Is it 12? 2.
How many people have to share just one of these pizzas?
3.
Yeah, 3 of them. Because if 6 people share 2 pizzas, then 3 people have to share 1 pizza. Well, if 3 people have to share a pizza, what fraction of that pizza does each person get? They get 1/3 of that pizza. Now, it doesn't matter how many slices this pizza was cut up into. It could have been cut into 3 pieces, making life easy, although those would be awkwardly big pieces. It might have been cut into 6 pieces. Okay. It could have been cut into 12 pieces. We don't know. What we do know is that out of that, each person gets a total of 1/3 of the pizza. And so 3 people share that one, 3 people share this one. And so that's a way you could get there. Now, I said that's just one way you could get there. How else could you think about it? Well, you could actually split every pizza up between 6 people. And so you could do one of these and say, okay, each person gets 1 of the 6 there. And then you could do the same thing with this one and say, okay, that same person also gets a 6 of this one. So the person is getting 2 of the 6th, which you'll notice equals 1/3 as well. That's another way you could think about it. It's less typical, but it could also work. Or what if you aren't the visual type? What if all this drawing picture stuff just isn't your style? What calculation would you do at the start to figure all this out? Well, how much do we have at the start? 2 pizzas. And we're dividing it among how many people? 6. So 2 divided by 6, and yes, that equals 1/3 of a pizza. Now, again, going back to the question about slices, we didn't know how many slices there were, so I couldn't answer it in terms of they get 2 slices or 3 slices or 4 slices, because we don't know how many it's cut into. And so if we don't know how many slices there are, our answer cannot be in terms of slices. It has to be in terms of how many pizzas there are, which is what we did start with.